This is the Reigate College Further Maths Year 1 Core Pure Booklet 1. Complex numbers, calculations and solving quadratics. To add two complex numbers, we're going to add together the real parts and we're going to add together the imaginary parts. So in this example here, we're going to add together 2 and 4 to give 6 and 3i minus 7i to give minus 4i. If we subtract complex numbers, we subtract the real parts. So 2 subtract 4 is minus 2. And then just watch for the brackets here. So it's going to be 3 take away minus 7. So that's going to be plus 10i. When we multiply two complex numbers together, we multiply as though we're multiplying out of brackets, and we're going to get 8. Then when we multiply this pair here, we're going to get minus 21i squared, which in a moment we'll change to plus 21. Then we've got 12i minus 14i. Altogether, that's going to give 8 minus plus 21 there, because this I squared is minus 1, so we've got 29 minus 2i. Multiplying this one here together, 2 times 2 is 4, then we get minus 9i squared. And then because this is like the difference of two squares, we get plus 6i minus 6i, so there are going to be no imaginary parts to this answer. So this is going to be 4 plus 9, which is 13. And that's an important property of multiplying a complex number and its conjugate together. We're going to use this when we divide two complex numbers. So in order to divide two complex numbers, we multiply top and bottom by the complex conjugate of the bottom number. And so that's going to give me, on the top, I'm going to have 8 minus 21i squared. Then I'm going to have minus 12i plus 14i, and on the bottom of this we're going to have 16 plus 49. So this gives me 29 plus 2i over 65. And you can either leave it like that, or you might need, depending on the question, to write it as two separate parts, like that. If you go to a question like this, where you've got to find real numbers, x and y, such that this equation is true, then you're going to multiply these brackets out, and you're going to use the fact that if two complex numbers are equal, then the real parts will be equal and the imaginary parts will be equal. So multiplying this out and regrouping to get all the real parts together, I've got x here, I've also got y there, and those are both real. I've got minus 2xi, and here I've got yi, and that's equal to 5 plus 8i. So that tells me that x plus y is equal to 5. And it also tells me that minus 2x plus y is equal to 8. So these are simultaneous equations, which we're going to solve by doing this equation, take away this equation. So that gives me 3x, this equation, take away this equation, no y's is minus 3. So x is minus 1. and then we're going to say that y must be equal to 6. A question like this, if you're asked to find z, you're going to start by saying, let z equal x plus I, y. Then substitute in everywhere you see your x with your z with x plus I, y. So you're going to have x plus I, y plus 2 times x minus I, y, because this star means it's the complex conjugate, equals 3 minus 4i. So I'm going to do the same thing, equating the real and the imaginary parts here. So look, I've got x and 2x for my real parts, so that's 3x must be equal to 3. So x is equal to 1. And then I've got yi minus 2yi here, so minus yi must be minus 4, so y must be equal to 4. So my number z that I've been trying to find is 1 plus 4i. Let's give the complex number at the end. Moving on to page 2, where we are looking at quadratics. Show that z equals minus 1 minus 2i is a solution of this quadratic. So there are two approaches here. You can either substitute it in. So if we substitute this into this equation, then we're going to get minus 1 minus 2i squared plus 2 multiplied by minus 1 minus 2i plus 5. We don't put it equals 0 because we don't actually know that it is yet. So this is equal to, multiplying this bracket out, we're going to get 1 and get 4i squared. This is going to give me 4i plus minus 2 minus 4i plus 5, and that's equal to 1 minus 4 is minus 3, minus 5 plus 5 is 0, and we've got 4i minus 4i plus 0i equals 0, and a little tick showing that that shows that it's a solution of this. The other thing you could do to show it's a solution is you could actually solve this equation here, perhaps by using the formula. So you'd have to say z is minus b plus or minus the square root of b squared minus 4 times a times c all over 2a, which is equal to minus 2 plus or minus root minus 16 over 2, which is minus 1 plus or minus 2i. So that shows that minus 1 minus 2i is a solution. So either of these methods would do. Question 2. Given that one root of the quadratic equation is that, find the other root. This is a very straightforward question. Complex conjugate roots of quadratic equations with complex roots occur in pairs. So if one root is 3 plus root 3i over 6, then the other root is simply going to be 3 minus I root 3 over 6. And that's the question 2. Question 3. Find the two complex roots of this equation using completing the square. So we're going to start off with z squared minus 6z plus 10 equals 0. Complete the square. It's going to be z minus 3 squared minus 9 plus 10 equals 0. z minus 3 squared is equal to minus 1. Square root both sides. Z plus minus 3 is square root of minus 1, which minus square root of minus 1, which is plus or minus I. So z is equal to 3 plus or minus I. So the two roots are z equals 3 plus I and z equals 3 minus I.